When you talk to an AI like ChatGPT, it can feel, well, a little bit like magic, can't it? The way it writes is so fluent, so structured, it feels like you're talking to a person. But what's really going on behind that curtain? In this explainer, we're going to take a look under the hood.
For, well, basically all of human history, we thought that creating complex language was our thing. It's what made us unique. But as this source points out, large language models have really thrown a wrench in that idea. They can write stuff that looks and sounds exactly like something a person would.
And that really brings us to the core question, doesn't it? When you ask ChatGPT something, is there some kind of mind in the machine that understands what you want and is carefully crafting a reply? Or is something else happening entirely?
To answer that, we really do have to look under the hood. We're going to peel back the layers and see the one single mechanism that powers these incredible tools. And you'll see it has a lot less to do with thinking and a lot more to do with something else. Here it is. This is the absolute key to understanding everything. At its very core, a large language model doesn't understand, it doesn't reason, and it doesn't believe anything. It is a prediction engine. Its entire job is to look at a string of text and calculate what word is the most likely to come next. That's it. The technical name for this is next token prediction. A token is just the system's way of saying a word or even just a piece of a word. The entire massive, complex system is built on this one simple idea. Based on all the human text it has ever seen, what's the most statistically probable next piece of text? This chart is a great way to see that idea in action. So if you feed the model the phrase, "Mary had a little," it then calculates the probability for every single word that could follow. And because of the billions of examples it's been trained on, the word lamb has an overwhelmingly high probability. The model isn't choosing lamb because it knows the nursery rhyme. It's choosing lamb because the pure statistics point to it. So how in the world does it get so good at this? Well, it's a very simple loop that gets repeated an unimaginable number of times. Guess, check, and update. During its training, it's given a piece of text and it guesses the next word. Then it compares that guess to the actual word from the text it was trained on. If it's wrong, it adjusts billions of its internal numbers just a tiny bit to make a better guess next time. Now, just do that hundreds of billions of times and you get a really, really good guesser. But for a machine to work with words, it can't see them as, well, words. It has to turn them into something it can actually process. And this is where we get to the mathematical heart of these systems, where it learns the patterns of language, but the meaning itself stays just out of reach. See, the model works with math, not letters. So every single word, or token, is converted into a very long list of numbers. We call this a word embedding. The easiest way to think about it is like coordinates, placing each word at a very specific point in a giant, multi-dimensional space. And words that we humans use in similar ways, like king and queen, or cat and dog, end up being placed closer together in that space. And this right here shows you just how powerful that system is. The relationships between words become a kind of math. The distance and direction between the coordinates for man and king is almost exactly the same as the distance and direction between woman and queen. The model can figure out these complex analogies just by doing math on numbers, all without ever understanding what a king or a queen actually is. So this is the point we have to keep coming back to. The model is an absolute expert at recognizing the statistical patterns of our language. It knows which words usually show up next to other words. But that's all it is, a kind of statistical mimicry. It has zero grounding in the real-world concepts that those words are describing.
Okay, so what happens when a system that is built entirely on guesswork gets asked something it doesn't have good data for? This is where the whole probabilistic nature of the model shows its biggest weakness.
This is what leads to something called an AI hallucination. Remember, the model's one and only goal is to predict the most plausible next word. It is not designed to say, "I don't know." So if it can't find the correct information in its data, it will simply fill in the gap by generating a response that is statistically plausible but completely made up. And this isn't just some funny quirk. It has serious real-world consequences. There was a now famous case back in 2023 where a lawyer used an AI for his legal research. The AI wrote up a brief and confidently cited a bunch of court cases. The only problem was that none of those court cases had ever happened. They were completely fabricated because they looked like the correct statistical pattern for a legal document. This brings us to a really useful metaphor that researchers use, the stochastic parrot.
Stochastic is just a fancy word for based on probability. Think of it like a parrot that can perfectly mimic human speech. It sounds convincing, but it has absolutely no understanding of what any of the words mean. That's a large language model.
So, how should we be thinking about these things? If it isn't a mind, then what is it? I think the key is just to reframe our whole perspective and see the AI for what it really is.
This quote from one of the sources really gets to the heart of it. Everything we've talked about, the word embeddings, the probabilities, the next token prediction, it's all just mathematical operations. It's a mechanical process, not a conscious one.
So, you know that feeling that there's a ghost in the machine, a real consciousness in there? That feeling isn't actually coming from the AI. It's coming from us. As humans, we are just hardwired to see fluent language and automatically assume there's intelligence behind it. The mind we think we see is really just a reflection of our own.
So the next time you get an answer from an AI, especially one that sounds a little too perfect, it's worth stopping to ask yourself this one question. Are you looking at a verified fact that was pulled from a real source of knowledge, or are you just looking at a very well-worded, statistically plausible, and totally confident hallucination? Knowing the difference is a skill that's becoming more important every day.